Hi everyone, this is Melody Rondeau and I'm going to be walking us through, talking as well, the lesson on triangle mid-segments. This is found on page 77, I believe, in your notebooks. Should be right around there, triangle mid-segments. Our learning intention, I'm learning how to apply theorems about triangles, and our success criteria, I can apply the triangle mid-segment theorem to find missing values. If you have not yet grabbed colors, for the notes today, you will probably want to do that. I'm going to be using red, blue, and green in addition to your regular writing utensil. Those are the colors. All right, so let's go ahead and get started. See if I can get my pen to agree here. There we go. All right. So first of all, this one is our last theorem that we're learning in this section. So triangle midsegment theorem says the segment joining the midpoints of the two sides of a triangle is parallel to the third side, and its length is half the length of that side. Okay, so first of all, the mid-segments, in order to be a mid-segment, it must be this part right here at the beginning, the segment joining the midpoints of the two sides of a triangle. That's what a mid-segment is. So this part right here is what we mean by that word mid-segment. So that's a new vocabulary concept for us. Mid-segment is right there. So it's the segment that joins the midpoints. So on our picture, if you have your red, I'm going to go ahead and start with red, and I'm going to draw a point at K, and I'm going to say that K is the midpoint of side JM. The way that we mark a midpoint is to show that it's the same distance from K to J as it is from K to M. So K is in the middle, or the same distance away from those endpoints. And then also, if you will switch now and grab green, in order for us to have a mid-segment, that segment in the middle of the triangle has to connect midpoints. So that means L would have to also be a midpoint, meaning it's the same distance from L to J as it is from L to N. And so I use two tick marks here just to show that those two are the same as each other, but not necessarily the same as the other side. So a quick statement here, if my pen will show up. Come on, honey, I lost it. There we go. Okay. Here we go. And the statement is that based on what I have currently shown on my diagram, KL is the mid-segment. All right, so once I have a mid-segment, because this theorem basically says if I have a mid-segment, then it will be parallel to the third side of the triangle, and it will be half its length. So I'm going to go ahead with my regular writing utensil, and I'm going to trace the mid-segment here. So K to L is the mid-segment. I'm just going to trace over it so we draw some attention to it. And then based on the theorem, if I have a segment that, again, connects the midpoints, we call that the mid-segment, and we know that it is parallel. So remember, we use the arrows to mark parallel. So it's parallel to a side of the triangle. It also tells us something about the length, that basically the mid-segment is half the length of the other side, or it takes two mid-segments to make one whole side. So how we're going to write that is basically the mid-segment, which is K to L, would equal 1/2 M to N. So if I took the distance from M to N and cut it in half, that's how far it is from K to L. The other way to think about it is that it takes two distances that are from K to L, so two of those equal 1 M to M. So it takes M to N, excuse me. So it takes two mid-segments to make this side of the triangle that it's parallel to. So there are two different ways to understand it. One other thing I would like you guys to jot down is that it's 2 times the mid-segment equals the parallel side. So you'll hear me say this in our notes today. 2 times the mid-segment is going to equal the parallel side. And then once you have that, let's go forward. Okay, so U, V, and W are midpoints of their respective sides of the triangle. And so we have some different things that were asked for here. I'm going to start with, if I want to find UV, I'm going to go ahead and trace that. I'm going to start with, nope, I'm sorry, just changing my mind about how I want to start, guys. All right, let's start with red, actually, before I even get to UV. Since it tells us in the top part that U, V, and W are midpoints, I think I want to put that on my picture first. So if U is a midpoint, that means it's halfway or the same distance to R as it is to S. So I did that in red. Then I'm going to switch to green. I'm going to do the same thing over here. If V is a midpoint, that means it's the same distance to S as it is to T. And then finally, if W is a midpoint, so switch to blue. If W is a midpoint, it's the same distance to R as it is to T. So all of those are midpoints, which means we actually have, of the stuff in our triangle, we actually have two midsegments that we're going to work with. All right, so I'm going to go ahead and start with UW. So example 1, find UW. So I'm going to trace that one in green, and here's why. If I trace UW in green, hopefully we'll see this, how this works out. That would be a midsegment because I'm connecting midpoints, but also UW is across from, or since it's a midsegment, it's parallel to the other side of the triangle. So it would be related to that other side, ST. Okay, so if we want to find UW, we know that it takes 2 times UW to equal the parallel side. The parallel side to UW is ST. So if I fill in the values I have there, I don't know UW, I'm trying to figure that one out. But ST, we're told, is that total 10.2. To get that UW part by itself, I can divide both sides by 2, and I get UW equals 5.1. And awesome, so that's the answer for the first one. I'm going to switch colors here to blue, and the reason I'm doing blue is if I look at RT, it's kind of on the blue side over here. So R to T, this is not a midsegment, this is the side of the triangle, but I know that it's related to, or it's parallel to, the midsegment up here that is UV. So UV is the midsegment, it connects midpoints, and it is parallel to RT at the bottom. So I know those are parallel, but what I'm trying to do is figure out how far is it from R to T. So again, using that same idea we did a minute ago, it takes 2 midsegments, or 2 times UV is going to equal the parallel side, which is RT. And again, plug in what we know. We know that UV is 5.6, and we're trying to figure out RT. I can quickly multiply 2 times 5.6, and I get 11.2, and there is RT. All right, let's move right along to the next one. Oops, that's not what I want. Okay, so similar kind of situation here. We are given, we are not told things are mid-segments on this one, so we're going to have to figure out some of this for ourselves. So if I look at what's given, though, I'm going to trace over some of it in color. I'm going to start with red, if I could get my pen to show up. Come on, pen, there it is. Okay. So I'm going to start with my 1 tick marks. So I have J to P, or P to J, is the same as P to K. If those are the same distance, that means P must be a midpoint. And in a similar way, let's switch to green. Green. I'm going to go to my 2 tick marks over here. Oopsie, there we go. 2 tick marks and 2 tick marks. Okay, so there's my 2 tick marks, and if those two distances are the same, so the same distance from N to K as N to L, then that means N must be the midpoint. And then finally with blue, with my 3 tick marks over here, if I have the same distance from M to J as M to L, then I know that M must be the midpoint. So we have lots of midpoint things happening. We got a couple of mid-segments in there we'll get to in a second. All right, so we want to find JL. So if I look at where JL is, it's kind of on the blue side over here. So I'm going to actually trace this out. This is a side of the triangle, J to L, and that would be parallel to, I don't need 2 arrows yet, sorry. Here we go. It would be parallel to a mid-segment that we see inside the triangle. So over here in the triangle, we have mid-segment PN, because it is connecting midpoints. That's going to be parallel to JL. And if they are parallel and they're it's a mid-segment relationship, we know that it takes 2 mid-segments, in this case PN is the mid-segment, to equal the parallel side, which is JL. And again, we'll go fill in what we know. We know that PN is 39. And then if I multiply that, I get 78 equals JL. Well, the next one here for PM, looking at my picture, it looks like I'm probably going to need green because I see PM is here and it is a mid-segment connecting midpoints, and it is parallel then to this other side over here, LK. And so once again, using the mid-segment theorem, it takes 2 mid-segments, so 2 times PM, to equal LK. So here we go. I'm going to plug in what I know. I don't know PM, that's what I'm trying to figure out, but I do know that LK is 95. And I can quickly divide both sides by 2, and we get PM equals 47.5. All right, let's go forward. We, of course, have to shift a little bit and make it a little bit harder. Those were all done with numbers, and now you'll see we have variables, but we are going to use the same basic process. So I'm going to start with just looking at what I'm given. I'm going to start with some red here, and I'm going to use my 1 tick mark here. I see 1 tick mark here and 1 tick mark here, which means this point right there that I marked in red must be the midpoint. And I'm going to switch to green. And I have a similar thing. I have 2 tick marks and 2 tick marks, which tells me that this point here must be the midpoint. And if I have 2 midpoints and they are connected, the thing that connects them, we call that the mid-segment. So here would be my mid-segment. And I know that it is parallel to the side of the triangle. All right, the other thing I know in terms of finding the value of n is that it takes 2 mid-segments to equal the parallel side. So notice I just filled it out. 2 times the mid-segment, which is 6n, equals the parallel side. Then I'll go ahead and multiply. I get 12n equals 48. Divide both sides by 12, and we get n equals 4. All right, on to number 6, and this is the last one we're going to do today. When I'm back with you in person, we'll go ahead and do example 7. So we're going to wrap it up with example 6 today. So here goes. Once again, looking at my 1 tick marks in red, I have those 2 tick marks. That was terrible. Let's see if I can do a little better. And again, they're marking off the same distance. So same distances here. That means that this point in between them must be the midpoint because I have equal distances. And then in a similar way, I'm going to switch to green with my 2 tick marks and 2 tick marks. That means this point here must be the midpoint. And if I have a segment connecting midpoints, we call that the mid-segment. And we know the mid-segment is parallel to a side of the triangle. And once I have that, then I'm ready to try to figure out what n is. Once again, I know it takes 2 mid-segments, and here the mid-segment is n plus 12, to equal the third or the parallel side. parallel side. Okay, so that's the equation I come up with. Again, 2 times the midsegment equals the parallel side. I'm going to go ahead and distribute to solve this out. So 2 times n, 2n, 2 times 12, 24, equals 6n. At that point, you have some choices about how to solve. I'm going to put my n's together, and since they are on opposite sides of the equal sign, I have to do those inverse operations. So subtract 2n from both sides. That makes it go away on the left and equals 0. And I have 24 left over. On the right, 6n minus 2n makes 4n. Divide both sides by 4, and we get n equals 6. And like I said, we're going to wrap it up there. We'll come back and do example 7 together. So please take a minute and check off your success criteria. I can apply the triangle midsegment theorem to find missing values, and then check in on Google Classroom to see about your practice assignment. All right, we'll see you later. Bye.